Oh my goodness, we've done a lot of work on this graph. We've taken our raw data set, we have made a process data set, we have made a graph, added the title, labeled the axes appropriately, even put in error bars, or uncertainty bars would be a better name for them. The last thing we have to do is to find a line of best fit. That means, is there a systematic pattern in my data? Good news again, just like calculating average, just like calculating standard deviation, the computer can do lines of best fit for you. What we have to do is go on our graph, select one of our data points. Now they're all selected. Go up here to the plus sign, which is about how to edit it. Again, don't just choose this option here, because if I do, notice how it underestimates points in the middle, overestimates the ends, an indication that it doesn't match my data set well. It also doesn't go through that error bar, and it doesn't go through this error bar. If I can find a best fit line that goes through my error bars, then it's a better predictor of my data. So instead of check this, I'm going to uncheck that, and I'm going to click on this triangle on the right. And I don't want any of these. I can try them. See, it doesn't fit inside all my error bars. That one's even worse. This one is pretty much like linear. This is for something in a different math function. So let's choose more options down here. So here's just the same things that we tried. Is the exponential best fit line work? Nope, terrible. It falls outside almost all of my error bars. How about linear? Much better than exponential, but doesn't really fit inside there. It's at the very top of that one, and I'm not sure if it goes through that one. Let's try logarithmic. That's worse. How about polynomial? Wow, look at that. It actually goes through those error bars. Now that might sound like I just made that up, as if a polynomial function is not a real thing. But in fact, polynomials are real. The one that you're probably the most familiar with is a quadratic. Remember that a quadratic equation is in the form ax squared plus bx plus c. The x squared means that it is a second order polynomial. This particular curve is the same curve you would find in a parabola then. It's not the whole thing, it's just a section of one of those curves, but that shape represents or estimates or predicts my data set very well, and it goes through my uncertainty or error bars at every point. And look how close it even approximates the means. That is an amazing fit. So I'm going to use that one. Now, how much latitude do you have for choosing error bars? Well, don't go crazy, okay? These are something totally different. They don't match. Power isn't appropriate probably most times. Choose from either exponential, linear, logarithmic, or polynomial. And when you choose polynomial, you can go up to second order, which is a quadratic. Occasionally, you can use third. We may do that in one of the next units, but that's the limit. You shouldn't be going up to polynomials past third order, like x to the fourth, x to the fifth, and that sort of thing. Those are not, those curves do not match naturally occurring patterns in most cases. So here, I'm just going to leave it a second order polynomial. And because I'm so stoked about my equation, I'm going to scroll down a little farther, and I'm going to display my equation on the graph. I'm going to move it a little bit out of the way here, so I can still see that other stuff. Let's see what just happened to my material. Label options. Okay, I'm going to close it and then go back into my data set, back to trend lines, back to more options. Okay, here's my window. So my equation is displayed on there. Good. Now it's on there. Whoa, it changed that, didn't it? There you go. Now it's on there twice, and I don't need it on there twice. Alrighty, come on, computer, help me, don't fight me. Trend line, more options. If you have ever heard of a correlation, you can include the R² value. But if you use it, be ready to explain it. Okay, so don't use it if you don't know what it is. But if you do know what it is, you're welcome to put it in. You do know what a linear equation is, or an equation that explains the curve of a parabola, a quadratic. So feel free to use those. And you may be asked to discuss or explain that in your conclusion. All right, thanks for watching this video about how to find a best fit line for your data set.